We have this problem right here, and we're asked if a circuit has 3 nodes and 3 loops in it, then it's which of the following? Well, it's not none of these. It is possible to determine, and so we are left with these two, as well as this one right here. And we're going to show that A is the correct answer. Both nodal and mesh analysis will require solving the same number of equations. And it's the same number of equations because when we look at something like this, if we were to take out this resistor, because we have 4 nodes here, we would not have a node right here. So our only nodes would be these two, and then this one right here. So when we look at something like this, we have these 3 nodes, and we have 3 loops, like it asks us right here. We are going to need the same amount of equations. So if we actually go to this site, which is linked below the like button, we have Kirchhoff's current circuit laws. And so this is going to give us a lot of information about the current law, which is the nodes entering the node is positive, and the nodes leaving the node, going out, is negative, and vice versa. You can switch those around, just got to stay consistent. And then you have Kirchhoff's second law, which is the voltage law, and that states that in a closed loop network, the total voltage around the loop is equal to the sum of all voltage drops within the same loop. So essentially, if we have voltage going around here, if we were to add all the voltages together, it would equal 0. And so we have some of these definitions right here, common definitions, and then we have an example here. So if we were to use the Kirchhoff's current law, we have at node A this, and node A is this right here, and I will actually look at it in depth more. So we have all the currents around this node right here, and that is for this node. Now we have node B, which is down here. We have the currents at this node. Now, if we were to use KVL, which is Kirchhoff's voltage law, then we would be using, we would be looking at the voltage here, over here, and over here. And so we would need to look at the voltage around terminal A and terminal B. That would still yield us with 2 equations, although they are going to look different than this. So knowing that, we can go back to our question, and we can see that clearly both nodal and mesh analysis require solving the same number of equations. It's not asking us which one is faster. There might be one that's faster, but regarding the same number of equations, they're both going to be the exact same.